Thank you. Our vision at KEEP is communities making informed energy decisions now and for a sustainable future. And our funding comes from the 6 investor-owned utilities whose logos you can see at the bottom of the slide here. And we work closely with them, with their communications team and so on, meeting with them quarterly, and also really focus more recently on clean energy careers, since that is a direction that the utilities are taking as well. And we'll be talking about that a little bit as we go along here. As I was mentioning to Andrea, we have story maps that we use as well. Probably the way that is most accessible, has been most accessible to us, because at KEEP we are not GIS specialists, but Arcgis Online has a really fantastic product, the story maps. So we actually use story maps to tell the stories of our energy educators of the year. And this is just a screenshot of that, but from the screenshot, you can see the locations of each of the recognized teachers over the past couple of decades. We see a thumbnail image of them. And if this were a live link, you would also be able to see a short biography and what the accomplishments of those teachers are. Another place that we're using our GIS Online is to tell the story of schools that have gone solar. So this is Wisconsin schools with solar dashboards, and we curate this map for all schools in Wisconsin. And a mirror of it is also on the Renew Wisconsin site, where they show all solar installations that are non-residential in Wisconsin. But we have more detail, more granularity to the map that we have. The gray dots show all schools in Wisconsin. The yellow symbols on there are schools with solar, and the purple symbols are schools with a solar dashboard. So whether or not you have solar on your school, you can use this digital resource that we have to guide your students towards exploring and learning about different schools, the energy production that they have from their solar systems, or maybe if you're looking at it even from a user experience, how different dashboard tools kind of guide their users and exploring how learning about energy. So Sunny Portal is going to look different from Fronius and so on. And this might mean nothing to you. It doesn't really matter, but if it does, I think it's a cool way for students to look at that as well. Our partners at Green and Healthy Schools Wisconsin use story maps to tell the story of schools that have achieved Green Ribbon School recognition. And really one of the advantages of story maps is they're very easy to update. You're essentially just constantly adding on to the data and editing it without having to do a whole lot of, really there's no coding there. You put data in, you take data out, and then it looks really beautiful. They have 6 or 8 templates, and they're all really lovely. So getting into the heart of our presentation here, I guess before I launch into that, are there any questions before I move on? All right, excellent. So main purpose of this training really is to build teacher skills and capacity, and for you all to have the opportunity to network with one another. So I encourage you to use the chat if you see something or an idea pops into mind, or you want to be like, hey, I use that. Feel free to put that in the chat or to unmute and speak up. We're a small enough group that we can do that. But also, we do want to take a look at the lesson, the solar energy potential lesson. So we're going to be exploring that next. While we're doing that, I'll take you and we'll just spend a couple of minutes looking at a solar dashboard, and then I'll introduce our guest presenter, Doug, who is here online with us, and he'll be sharing with you why GIS is an important part of critical spatial and visual thinking, as well as Esri resources that are available to all K-12 educators, really. They're available to anyone, but Esri's done a fantastic job of making resources available to classroom teachers. And hopefully discussion and suggestions will happen throughout, but if needed, we have some space and time reserved at the end for that. And we do ask that before you leave today, if you could please evaluate the session. It's just a 3-question questionnaire survey that we have, and helps us make our products better and reach you in better ways. So I think my colleague Gina is dropping into the link into the chat, but we're going to go over and actually take a look at the featured lesson here. Give me a moment while this transition, and I need to hide my floating panel. There we go. And I'm going to first take a look at this with all of you, kind of from a bird's eye view of our lesson. We have our lessons designed around the 5 E's of engage, explore, explain, elaborate, evaluate, and we can add a 6th E of extend here. So all of our online slide decks that we have available to teachers are built in that way. There's the introductory slide, the land acknowledgement, if you choose to include that. And then our slides also have, some of them have an icon in the bottom right-hand corner, and that's cued to the teacher that these are slides to remove their notes for you. So we'll go ahead and take a look at that particular slide there. From this slide, you can link to the teacher answer key, that is the answer key to the student worksheet that is linked to this lesson. So that's sort of the overview of that part of the lesson, and I'll go into some of the detail of the lesson momentarily. But then at the end of each of our lessons, we also include academic and career planning that's integrated into the lesson. So in this particular one, we have a feature on solar site assessor as well as solar energy technician. We've partnered with Slipstream over the past couple of years, and so far have 7 videos in a clean energy career series. And so if you pop in and zoom in on this particular slide, there's a link here where students can learn more about what a solar site assessor does. They can cruise the IREC solar careers map, which is super fun, even if you already have your career all figured out, because they did such a nice job with it, very intuitive, and watch the video. And our videos are fairly short. They're 5 to 6.5 minutes in length. And if you do use our resource, again, please take a few moments and give us some feedback on that, because we would like to be making excellent resources, and we don't know what you think of them unless you tell us. So please do that. Any questions so far? All right, so we're gonna go in, and if you wanna jump ahead, if you have 2 screens, or if you're just sitting back relaxing, that's super cool too. But I'm gonna jump ahead to slide 9 in this particular lesson, just to give you an idea of sort of how we pull students in and integrate ArcGIS into this particular lesson. So it's really beautifully done. Credit goes to so many people who are in this room. I'm just the one delivering the talk today, but many, many people here, Annie Baker, who was our previous program coordinator, and Gina Smith, who is our curriculum and resources coordinator for both KEEP and LEAP, have just done a phenomenal job. I just have the privilege of being able to share this. So coming into here, students just have one hyperlink that is on that map that'll take them here, and we're going to go there together, but you can kind of see that there are directions in here with the bolded letters. So we'll go on in and take a look at what for example, the first step that your student would be guided to do on here. Actually, I'm going to go here because I already have it populated. And turn that off. So when a student links to the map, it opens here, and the directions guide them to go down to the 3 dots to adjust the transparency. So it would start off at 50%, and they can make it completely opaque. From there, they can also then learn to open up the legend that is there. And if they're not as familiar with what solar potential is and kWh per meter squared would be, this is an opportunity to talk about insolation and have them think about, where do you think there would be the greatest solar potential? Where is there more sun striking surface areas on parts of the planet than others? So the Andes are the place where that is happening the most, we have the highest value. So the warmest colors are down in there. So they're close to the equator and high altitudes. And so low latitude, high altitude. So that, for instance, would be the first slide there. And then students get to expand their knowledge and learn how to navigate through ArcGIS Online, going to places. So they're asked to find what's the solar potential for where they live. And the nice thing about, sorry if I'm making you dizzy there, zooming in and out. One of the nice things about this map is you can't break it and your students can't break it. You can click on all the things you want to click on. You are not going to mess up our product. You just have the ability to turn things on and off and get information, combine information, but you can't change the information. So don't worry about that. So I'm actually reporting from Oshkosh, Wisconsin. So I can find out what the solar potential for Wisconsin is just by searching it, but all I'm seeing is a big green blob here. So I actually want to like zoom out and be like, is this map even going to the right place? I have to zoom out quite a bit to get there. Okay, yeah, that looks about right. Another way your student might want to find that is they turn off all that bright color that's there, and they could actually zoom in on the map and find themselves, oh, yep, there I am, and there's my house right there, and then turn this back on and be like, okay, oh, here we are. Okay, so what's the value there? 3.8. So doing things digitally, it's not doing it right. It's what is the most elegant way to do it, and we each find our way to do that. There isn't a right and wrong way. Well, sometimes there is, but in this case, there isn't. So going on through this lesson, once students become comfortable with the navigation, knowing how to toggle into the options here and opening up the legend, then we invite them to go in and start looking at the solar dashboards. That is a layer that we've provided with you, and that has been populated with dashboards across latitudes throughout the world here. And so taking a look at that, then students get to then look at the tables. So this is another functionality of ArcGIS Online, is you can take a look at the tables, and students are asked to provide the information for what three systems had the greatest annual yield in 2020. So here they get to learn the sort function. They're going to sort them from largest to smallest. And if I jump back over here to the lesson, I need to find this slide here. I think this is the one here. Yep, so this shows the student as they're going through it, if you followed the directions correctly, then the one producing the most would be Sandia Heaven. And indeed, when I look over here, Sandia Heaven is the one that has produced the most in 2020 of the ones we provided on here. So students get to have that confirmation as they're going along that they're doing the lesson correctly and they're answering questions as they go along there. Are there, I'm gonna just pop open the chat here. Because I see people are dropping. Thank you for those, Gina, for dropping the links. Are there any questions before I move on? That have popped up? Okay. I will now diminish all of you. All right. Thank you. So moving right along, then students are asked to use that skill that they had learned a few slides previously, and to find a particular system in Cape, Alaska. So they might think they know where Alaska is, and they're like, Alaska is north. So they will go click on this system on Great Slave Lake, only to discover that, the Yukon is actually not Alaska. So they might figure out that it's there, or they can use the search bar to get there. And either way, they should end up at this point here. Once we end up at that point, I'm going to pull this down and pull all this down. Hopefully the information will come with. There we go. We can click on more information, and that will actually take us then, excuse me, to the solar dashboard for that particular location. Excuse me while I hide my floating panels that have reappeared. Here we go. So the lesson has students explore the Elks House solar array that is there. And the particular question is year over year, looking at the average yield expectations versus what the actual observed values are. So this could be something as simple as having the students click on there and then, oops, excuse me, navigating, and they can actually then calculate their own average based on the total yield for each year from 2015 through 2021. There are other metrics that can be explored and discovered in going through here. For example, excuse me, you might ask students to look at the generation. Here we're looking at the month of February. We can see there are days with high production and less, and then there's tiny days. So what's going on? Is it that, that there's snow on the panels? Was it a particularly cloudy day? And I'm going to draw your attention here to the y-axis, because here we can see like sunny day, cloudy day, kind of cloudy, sunny day, something's changing on. If I go back to January, so notice this one, we're up at about 18. The high in January for production was here, right around 7.5. So something to draw all of our attention to when we're interpreting graphs is to really pay attention to the axes. So the software here is designed in Sunny Portal to modulate the y-axis based on the maximum value in that month. So students might think, oh, yeah, a lot of electricity is being produced in January. Well, not if you're reading your axes, you can understand. And then here, right at the beginning of the year, there's like, the sun is barely getting over the horizon. There were 10 degrees latitude north of us. How do I know that? Because I looked it up earlier today. I looked at it. They're at 55 degrees north, and we're about 45, 46 where we are here. So that's sort of a quick overview of what's happening in the beginning part of this lesson. And then going on, students are invited to explore biomes. So turning that layer on, as we give it a moment here, and I'm going to click the home button here, and that sort of centers our global map here, looking at the biomes and exploring what solar energy potential is there. And I'm actually going to just minimize that so we can see all of our layers. And then the lesson concludes, and this is, I think, probably my favorite part of this lesson, is having students explore the continent of Africa and the many challenges and influences that there are both on human settlement as well as challenges. There are lots of challenges there. I'm going to turn these layers on and we can kind of collectively think about that. But we have solar production by country. And actually turn that one off. So we have solar production by country here. And this is in terawatts of generation. So we can see where a lot of electricity is being produced. We can see where the power plants are located globally once it turns on here. There we go. I'm going to minimize this. And this is access to electricity. So we need to have the legend on here. So the blue areas are the areas with greater than 90% access. The gray areas are less than 10% access. And we can see in the heart of the African continent that there is very low access to electricity in that area. Another layer that's provided on here as well is the MENA region so MENA is the Middle East and North Africa World Bank definition of that region of the world. So we can actually take a look at what the distribution networks are. And so some really great questions that can be asked about. These are some parts of the world with the greatest amount of solar energy potential, but with some of the least amount of distribution. So what are factors that go into deciding who gets electricity, where it's generated, who owns the generation and distribution that's there? Righto. I'm going to pause there. Are there any questions or feedback at this point? All right. Thank you. So then I'm just going through the lesson here. I'm taking us to the last slide. That's one of the last slides that's in the lesson. That is kind of an overview of what I just went through with you on the ArcGIS map that's available there, just so you can take a look at how students would be guided through that as well, and doing their own exploration and evaluation for solar energy potential energy generation. So with that overview of our lesson, I am going to switch over if I can. I know how to do this. I know I've done this before. There we go. I am going to switch, hand this over to our guest presenter, to Doug Miskowiak from the GIS Center here on campus. So he teaches full-time, but he's also an Esri GIS mentor. And before I have him share his screen and start talking, I took a screenshot of all the schools in Wisconsin that already have installed Esri licenses. So you might see yourself on here as well. And please tell your colleagues about some of the great opportunities that are available to you. So with that, I'm going to stop sharing and invite Doug to turn on his mic. And if you want to share your screen,
really good.
Yep.
Let's go ahead and get to share screen here. There we go. I think I need it enabled, Samara. Host disabled participant screen. There we go.
I got it.
Oopsie. Let me just switch this the other way. All right, I think that's better. All right, thank you so much for the introduction, Samara. Again, my name is Doug Miskowiak. I'm the GIS Instructional Administrator here at UW-Stevens Point. And my primary role is teaching in geographic information systems at the university. I teach to well over, probably 250 students annually just in geographic information systems. So hopefully you'll get a chance to work with some of our students in the future. But in addition, I also conduct outreach projects, mostly with Wisconsin communities. And in my current outreach work, I'm trying to engage more with the K-12 community. But typically, when people think about geography, they think about geography as a place name science. And quite frankly, it's significantly more than that. You can think about all of the questions that might begin with the word where, and geography and geospatial thinking are habitually relegated to this knowledge about where something is or occurs, kind of in the same way that history is relegated to knowledge about when something happens. Geography, after all, is called a spatial science for a reason, but geography is so much more than just where. It's also interested in the how and even why something happens, and why and how that something is significant in some sort of way. Declarative geographic knowledge, of course, focuses on the collection and representation of physical and human facts related to where they exist. Like, for example, very simply, Dane County is located in Wisconsin. Wisconsin's last glacier stopped in the middle of that county. Dane County's eastern half contains rich, deep prairie soils. Those are all examples of declarative knowledge. But geography also attempts to understand the how Earth's complex natural and cultural systems function. and interrelate, and why those geographical contexts matter for making decisions that affect place. So humans can use the collection of geographic facts and then use deductive and inductive inference and even logical reasoning to address the how and the why questions of geography. Like, why is it that Eastern Dane County has rich prairie soils while Western Dane County does not? Relating soils data to the last Wisconsin glacier, we reasoned that the glacier scraped and gouged Canada's and Wisconsin's northern soils and deposited them in east of this last glacial extent, leaving Western Dane County void of many high quality soils. So geography is a science of where, but it's also a science of how and why where matters. Even Esri, the vendor of the software that we make, describes geography as the science of where, but they also acknowledge that geography provides an incredible framework and even a process for addressing questions that might not be just related to geography, but might be related to biology or natural resources or agriculture or human systems. And geography and geospatial tools give us the ability to measure those phenomena, to visualize and map those phenomena, to share a message, to communicate an idea, to analyze and model it even further, to try to build an understanding, to address the how and the why, and then to use that information to plan different futures for geography, take our existing conditions and maybe change them to some more sustainable or resilient state, and then use that information to inform decision-making that hopefully leads to sustainable and resilient actions. Now, this presentation is typically dedicated to GIS in the K-12 classroom, and these are some of the bullets that I'm going to describe in the upcoming slides. And the first is based on research conducted by Lynn in 2008 and Lou in 2010, where they talk about GIS and having it encourage critical thinking. The research suggests that the utility of geographic information systems, much like what you saw in the GeoInquiry and the Solar Dashboards project, helps to encourage higher order learning outcomes out of our students, that they then focus on analysis, evaluation, and maybe even creation instead of just remembering and recalling and understanding. And the reasons that the researchers suggest is that students spend less time in data collection, less time in representing data. And if you took a look at that solar dashboard, it beautifully showcased already collected data, highly curated data sets, beautiful data sets that are already represented. So students can focus their time on analysis and interpretation and decision-making and understanding patterns, trends, and relationships. Some research that I conducted in the Northwoods, this happened with citizens in Wisconsin. It wasn't students, but the citizens in our Wisconsin Northwoods were wondering why birch trees were dying. And of course, they conducted their own citizen inventories and had verified the death of birch trees, and then started to come up with various hypotheses, like, are birch trees dying because of a pest, because of a disturbance like fire or a wind throw? And then we started to talk with different local scientists. And then they started to ask questions like, well, when was Wisconsin's last cutover? And it was in the late 1800s to the early 1900s. And we started asking questions, well, how long do birch trees even live? And they live to be about 80 to 100 years before they start to die off naturally. And it turns out that this story in the Wisconsin Northwoods is not a story of tragedy, but rather a story of triumph that based on what we've seen in data, here we see the pre-settlement vegetation, the conditions that our original surveyors saw between 1833 and 1856 in the Wisconsin Northwoods, that birch trees are, yes, dying, but because they're being succeeded by the area's climax species of hemlock and sugar maple. And the data help to showcase that that hypothesis is true. But teaching with geographic information systems can also promote global awareness. having the ability to take data and overlay and compare that data with other layers helps to facilitate the analysis of the interconnectedness of our world, whether it's the physical and natural features and how they might relate to the human and cultural features and how humans are impacting their environments, to establish evidence for causality. So GIS is a really wonderful tool for identifying patterns and trends and processes that are spatial or geospatial in their nature, related to things, objects, and phenomenon at or near Earth's surface. Now, there's a reason I chose this industry, and it's because I am a very visual thinker. I'm also a very spatial thinker, and to see something in words doesn't necessarily grab my attention. It's when those words are shared in a graphical form, and it can be a table, it can be a graphic, but of course it can also be a map. Research shows that when the information is presented in a visual format, it's much easier to build those areas in the brain that have the ability to then recall that information. And of course, out of all of the available information to us, 80% of our information at the world is related to a location somewhere at or near Earth's surface. This one's very interesting to me, instilling a sense of place. Place is much more than just its location in geographic space. Place, we all know, has character. Like when we describe the place called the Northwoods, that place has meaning to us in some sort of way. It is imbued with some sort of value because it's the places where we live, the places where we work, and the places where we play. So it helps to guide our social interactions with other cultural beings in our locations. Moreover, because it's places where we live, it can also hold the ability to stir emotion. And that leads us to effective learning. Effective learning is concerned with how learners feel when they're learning. Effective learning is learning that relates to students' interests, attitudes, and motivations. And if students are connected to the subject area, at least emotionally, they're more likely to learn from those experiences. And the story that I have is actually a story about teaching politicians and policymakers at the United Nations about the crisis in Darfur. Now, this story is now relatively older. It happened in the 2000s. And at that time, it was only speculated that genocide was occurring in Darfur, but nobody was able to do anything about it because peacekeepers weren't allowed to verify the occurrence on the ground. And the words shared verbally, or the words shared literally on the written page, didn't have the impact to engage peacekeepers to take action. Instead, the peacekeepers browsed aerial images via Google Earth and noted that whole villages that appeared just months earlier were now burned to the ground. It stirred the emotion in these policymakers at the United Nations to finally take action. But before the map was allowed to do its job, unfortunately, 200,000 people had already died and 2 million people were since displaced. But the map held the emotional capability for policymakers to learn and then take action. My last one in that regard is geography is often described as a unifying discipline. Geography is our world's oldest science given to us by the early Greeks, in which many sciences then descended from geography. And because of that, it has the ability to bring disciplines together with common measurement tools related to geography. Geography and GIS give us tools to measure things that are related to history, related to biography, related to economy, related to cultures. And it has us the ability to ask questions about the environments and use the geospatial inquiry method to go ahead and build an understanding and then hopefully act on good information. I'm going to stop there for just a moment to see if there's any questions related to the benefits of GIS, at least promoted by myself with the group. Now, of course, there's also significant barriers to utilizing geographic information systems in the classroom. And these are the ones that have been reported by ESRI over I think about well over a decade, trying to engage teachers and students in the K-12 classroom. And it's something that Esri has spent a significant amount of time trying to overcome. Of course, you can add to this list. I'm sure for those of you that have tried to use GIS in the classroom, you might have your own significant barriers, but it takes time to learn these tools. And when Esri was first releasing tools well over a decade ago, they were trying to release desktop solutions in the classroom. You'll have noticed that the solutions that Samara presented to you and the solutions that I'll present to you are now available to you in the cloud without downloading any pieces of software. And that's very helpful when schools have patchworks of computing and network abilities. Of course, there's rigidity in the schedule. You've got classes that you already that are already necessary to teach, and you don't always get the support that's necessary. And Esri has provided various curricular solutions to try to eliminate those barriers. So there's no single tool. I'm going to only talk about a few here today, including GeoInquiries, but there's other tools and resources. And I think Gina is going to provide you a link on the chat here shortly related to each of these curricular solutions and how Esri describes them on their webpage. And the first is GeoInquiries, something that the Solar Dashboards projects mimics really well. And just kudos to folks for putting together such a beautiful tool to showcase patterns, trends, and relationships as they relate to solar capability. But GeoInquiries are meant to be short, standards-based inquiry activities for teaching map-based content that's commonly found in textbooks. Each activity is designed using a common inquiry model and can be presented relatively quickly from either a single computer and a projector for the entire class, or students can also access them themselves in a computer lab. But if you take a look at the topical areas, there's typically anywhere from 15 to 20 type of GeoInquiries, very similar to the Solar Dashboards project for each of these areas in K-12 education. And here's a different example that I won't demonstrate here today, but you can see this one's dedicated to marine debris, using the GeoInquiry process of engaging, exploring, and explaining. Each has a URL in which you can access the maps and the activities simply from using your favorite web browser. And the map is also available using your favorite web browser with all of the data curated with the symbology. So again, your students don't have to collect the data. They don't have to represent the data. They can focus on those higher order learning outcomes of analysis and evaluation. Of course, there's also Arcgis Online, and it gives us the ability to use a web browser to build our own maps without a desktop solution. Now, Esri provides all of their software free to every K-12 institution in the United States. And just a few years ago, they extended that to every school, K-12 type of school throughout the world, actually. And that gives you the ability to use a web browser and engage with Arcgis Online. And in that regard, you can take collections of data provided from other individuals. Like many times I will publish my data online, and that leaves it accessible for other students, other teachers, other researchers to use my data for their purposes and build their own maps with it. And take my data and analyze it and build their own data from it, and then share those ideas with other individuals that are accessible with nothing more than a web browser. Of course, Storymaps. Storymaps are probably Esri's best platform for sharing those stories very powerfully, where they mash up not only the map and very beautiful and dynamic maps where you can zoom in, turn on and off layers, click, learn a little bit more about our environments, but you can also mash up your text, your 3D scenes, your visualizations, photography about a story, and even videography. So now I don't even have my students use PowerPoint to present their work to me. They engage mostly using the Storymap platform. And if I do have time, I'll show you some of the story maps that my students have made for some of my courses. Their first introduction to the platform. I don't even teach story maps to them. They learn the platform themselves by going through the intuitive step-by-step process that Esri provides. The Living Atlas is a collection of data that you can grab online to build your maps. So there's many curated data sets that teachers and students can grab from to build the maps that they'd like. And some of them are even live feed data sets, like the World Traffic Service, World Imagery, satellite data, soils data, a whole host of other data sets. And here's where I'll stop. I just want to remind you that Esri provides their school mapping software bundle free of charge. Every K-12 institution in the United States, every K-12 institution throughout the world. And I think there's also a link that Gina will provide you. So I'll stop the share for a moment to see if there's any questions. And if we have time, I'd love to share with you some of the maps that some of my students have been engaging with.
Thank you so much, Doug. I just want to start life over and do it right and go into GIS full time. It's so exciting. I feel my heart fluttering thinking about this. So thank you. And I would love to see what your students have made. And Andrea shared that she uses story maps as well. I don't know if you have any handy that you could share. I'd love to see what our K-12 students have made as well, and or just share how, what the assignments that are used for story maps in your class are.
Sure, I can just briefly share this. I was in Alaska until this year, so we were using them there, and I would have students post pictures of phenology in their villages and share them, because I had distance learning classes there, and they would share them with each other by making little pin drops and on the maps. So we would share maps and do little virtual tours of each of their communities.
Fantastic. But of the other people who are in the session, has anybody else used story maps or have questions about it? Because it is such an accessible tool. Or maybe even if you want a quick demonstration, I don't know if Doug wants to go behind the scenes and show you just how quickly a story map can be built as well.
I'd be happy to do that.
So why don't you do that, Doug? Show us just the sort of what the platform that Esri has for that is, and share with us maybe one or two examples of story maps students have built.
Am I sharing the right screen with you with the Beckman Mill?
Yes.
Yeah, this is one. This is my 100 level course called the Geospatial Revolution. And at the end of the semester, they take things that they've learned about the geospatial perspective, and they start to use story maps to tell a geographic story that they care about. In this case, this student, this is a very personal story. This is his historical property that his great-great-grandparents had owned in southern Wisconsin, in Beloit. So you can see how this student started to mash up photographs and text, and then the story becomes navigable as you scroll through the story. And here's the map that they created. And in this case, this map was a template the student was able to grab and then zoom in on this map, add the map to the story, and then add these pins to the map to learn a little bit more about different portions of the property that his grandparents had purchased and then developed over time. And so started to add story elements. So a very beautiful way to navigate the story. Even had tools like this. Now, the student used this to integrate photographs of before and after, or history and then today. But these can also be maps where you can see a past map and a future map. But in this case, the student used the swipe tool for photography. It was interesting how folks out west used it years ago. There was a mudslide in Washington, and they showcased the maps before and after the mudslide. It was very compelling information, very emotional too, because you saw the entire village wiped off the map with the mudslide. So that's one of those resources. Let's see if I have another one. This student, Samantha, was very interested in geology. So
I'm wondering, Doug, did that first student who took a 100 level class, did they end up being major or doing a certificate?
It's too early to tell. I haven't been able to follow up.
Okay, because they really got into that assignment.
Yeah, this student, the one that I'm about to show, is one of our majors now, Samantha. And you can see that she's integrated one of the videos she collected while on a trip to a park in Illinois. And she starts talking about the geology, the hidden geology of Illinois. I never think of Illinois as a place that I ever want to be, quite frankly. And here she's telling a very beautiful geologic story about the Illinois River. And I think some of her maps end up being interactive. Let's see if I have another story map that I can share. Let's see, from another one of my groups, maybe. This one I'm going to share. This one's not from a student, but this one is from a project that we've been working on, but a student created it for us. And she integrated a series of beautiful dashboard products. So let me go ahead and get to my apps here. And we decided to submit our final report for a research project in Storymap form. Instead of submitting it as a PDF, we're now submitting it as an interactive document about COVID-19 and how communities have been preparing for the pandemic. And if we scroll through the story, again, generated by one of my students, she's integrated maps. Each of the maps are clickable to learn a little bit more about the characteristics of those places related to COVID preparedness. And then beautiful dashboards that tell a much more complete story about if these plans are available to the public, comparing Wisconsin, Michigan, and Minnesota. So here are dashboards in a very different sense than the solar dashboards, but another type of product that you could create with the story mapping tools. And again, I did not teach the student how to use story maps. I said, you know, if you want to learn how to use story maps, spend 1 week building a story of your choice. And then once you learn it, start applying it to our final report. And she did just that. I didn't spend 1 hour with any instruction on story maps.
So those are really beautiful examples of that you shared with us. Thank you so much for that.
Yeah, my pleasure.
I'm inspired by our students. I'm wondering if there's any questions, feedback from the audience who are here. And Doug, are there other than story maps, are there other eminently accessible products from Esri that a classroom teacher might be able to set in front of their students and say, spend a week on this and come back with your report type thing?
Yeah, sure. Let me go ahead and share screen again. I'll show you how easy it is to go ahead and create a map. So here's Arcgis Online. So once you have the Esri bundle, you'll all have access to Arcgis Online, and you'll see this top tab. And in the top tab, I'll go ahead and create a map. And so you can see it starts off with a series of base maps, and you can select really easily if you want to use imagery, if you want to use topo maps, if you want to use just a canvas to present a thematic story, streets. I'll go ahead and use imagery with labels. Start scrolling in perhaps. So all of those base maps are easily accessible, but you'll also see this add data button. And many times I'll contribute my own data sets, But if you take a look here, browse the Living Atlas, once you have access, you'll be given access to curated data, some by Esri and some from other individuals who are sharing their data free of charge from around the world, like the Natural Resources Conservation Service, maybe even our own DNR. So let's search for, I don't know, water.
While Doug is searching, DPI and DNR, like he mentioned, have some great maps that are available if we're looking particularly at education. Our colleagues over at LEAF also have a school forest map that's in the Esri platform that you can, that's available as a layer that you could integrate.
So here's the distance to water map. And my guess is you see in Wisconsin that we've got a lot of access to water, a lot of easy access to water. But you can compare those patterns throughout the world. And this is a data set that I just grabbed. This is not one that I was aware existed. But you can see how those patterns change throughout the world. Very interesting type of map. And again, available to you free from the Living Atlas layer.
Could you show us, Doug, quickly how we could learn more about that layer? Because I'm curious if this is potable water or navigable water.
It looks like navigable waters. So
okay,
let's see if I can learn more about the details of that data set.
I don't know if they provided it or not.
So show item details, and then it gives you a complete description, data set summary, what you can do with the layer, how it was created.
And I think for teaching, this is also just a really important tool when we're working with students and helping them learn about documentation, documenting where your information comes from and documenting your proprietary information, how important it is to do that, because the question I just asked wouldn't be answered unless somebody had taken the time to fill this out.
Yeah, it's a really good point. And metadata is very important. And every time I create data and publish it to the web, I try my best to include metadata, data about the data, so that it becomes useful to the individuals using it.
I'm just, oh goodness, I'm just looking at the time. I want to be mindful of the time because we're actually already 6 minutes over. My apologies. I got taken up with what we're doing here and didn't pay attention to that. I think all of us are happy from Keep are happy to stay online at least till 5:10 if people want to linger around and chat. But I think the last thing I definitely would like to do, in addition to thanking Doug for sharing his expertise and what some of his students have done. Thank you, Gina. If you could take a moment, please, to click on the link and evaluate this session. We would really, really appreciate hearing back from you on that, and we can continue with discussion and Q&A here, but I didn't want to forget doing that because Jamie would ask me tomorrow, did you do it or not? So yes, and feel free to nominate an Energy Educator of the Year. Thank you so much, Gina. We are accepting nominations for Energy Educator of the Year. An Energy Educator is really anybody who, not necessarily a classroom teacher, but could be somebody from facilities, somebody external to schools who helps schools be more energy literate and working with that. It could be somebody from your utilities, but if you have somebody you know, or just share that link, that would be great. And April 10th is the deadline for those nominations. Super. Yeah. So if we have other questions here, we're happy to take them. You guys can unmute, or here's your chance to grab Doug, who is a hard to reach, not hard to reach. He'll respond to you, but he has a very full schedule. So even the simplest question, this is your time to have him, because he is your resource. And what is a geo mentor? Is that what the title is?
Yeah, there's a map. I don't know if I have the link right now, but Wisconsin has a series of geo mentors that have made themselves available to address questions for K through 12 teachers. And there's hundreds of them in Wisconsin that would like to hear from you.
And the last link that Gina shared is we have, so the resource that we highlighted, we have an online course that it's about an 8-hour course that you can do. And in the link is also a code that you can take the course. It's normally $25 for free. So feel for coming to this session. You are invited to register and do the course. And we would be happy to have you complete it and use it with your students. All right, well, I want to honor everybody's time and thank everybody for attending today. We have one more of these sessions coming up on March 9th with a focus on math integration for high school students. And Holly Wera from New Berlin High School will be our guest that evening. So thank you so much and have a great evening.